Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today we're going to continue with our functions explanations, and we're going to focus on linear functions today. Linear functions and models, to be exact. Now, I want you to understand that we've already learned quite a bit, just about everything there is to learn about linear equations. A linear function is the same exact thing as a linear equation, except a linear function is a function in the form of f of x equals mx plus b. When you're talking about a linear equation, they usually write it as y equals mx plus b. But they're both the same thing, since y is the same as f of x. Remember that f of x is just a fancy way to write y. Okay, so a linear function is f of x equals mx plus b, where m and b are real numbers. The graph of a linear function, just like a linear equation, is a line, okay, whose slope is m, and whose y-intercept is b. Remember that the slope is a rise over run when it's positive, or fall over run if it's negative. Remember that the y-intercept is the y value on the y-axis when x is 0. Okay? How do we graph a linear function? Let's review it, because it's the same exact way that we graph a linear equation. Number one, you find and plot the y-intercept. Okay? Number two, you follow the slope, which is the m, both forward and backwards, for 3 to 5 points from that y-intercept. Remember that you always run to the right unless going backwards. So let's go ahead and just graph these two functions. I've got f of x equals 2x minus 5. We'll do this one in red. My y-intercept is negative 5, so I go down 1, 2, 3, 4, 5. That's negative 5. That's my y-intercept. And my slope is 2. Remember, there's an invisible 1 being divided here. That's the run. So I'm going to go up 1, 2, run to the right, 1, up 1, 2, 1 to the right, up 1, 2, 1 to the right. Let's go backwards. Down 1, 2, 1 to the left. Down 1, 2, 1 to the left. Easy peasy. Boom. Done. Let's look at B, which I'm going to graph on the same graph paper here, but in blue. My y-intercept here is 4. So I'm going to go up to 1, 2, 3, 4. And then I'm going to follow my slope, which is negative 2/3. Remember, regardless of if the slope is positive or negative, you always run to the right. So I'm going to go down 1, 2 over 1, 2, 3. Down 1, 2 over 1, 2, 3. Down 1, 2 over 1, 2, 3. Let's go backwards. Up 1, 2 over 1, 2, 3. Connect the dots. Make your line. And bing, pong, boom. There you go. It's done. Okay, so hopefully that jogs your memories, my brothers. Okay, remember that in order to find the 0 of any function, let alone a linear function, any function, you have to find the x value when y or f of x is set equal to 0. Therefore, simply set y or f of x equal to 0 and solve for the x. The x value when y or f of x equals 0 is the 0 of the function. I want you to understand that it's the same thing as the x-intercept, except when you write an x-intercept, okay, let's say it's 2, 0. That's the x-intercept. But the 0 of this value is the x value of the x-intercept. So the 0 would just be 2. That tells mathematicians, the reader of a math problem, okay, when x is 2, f of x is 0. So again, that's just a refresher on what zeros are. So for this second example, I ask you to find the 0 of the following function. F of x equals negative 5x plus 15. Okay. I'm going to set f of x equal to 0. And that equals negative 5x plus 15. Solve for x, my friends. Solve for x. Okay, I'm kind of going fast here because I know that all of you know how to solve for x by now. So x equals 3. So what is my 0 here? My 0 is 3. What does that mean? That means that for this particular function, when x is 3, f of x equals 0. Hence, it is the 0 of the function. All right, nice and easy. This is all review. And now, the fun part, the application of linear functions. There are many applications of linear functions, okay, guys? They're used in everyday life. A lot of business applications. When you're having fun, a lot of applications for that. When you're buying things, when you're selling things, when you're sometimes doing taxes. There's a lot of applications for linear functions. In order to master the application of linear functions, it is important to remember that the f of x or y, remember they're both the same thing, but the f of x represents the dependent variable. It depends on x, okay? And that the x represents the independent variable. The independent variable depends on nothing. Keep in mind that time is always independent. Okay? Doesn't matter if you're happy, sad, mad, glad, or afraid, time is going to pass. The sun is going to rise. The sun is going to set. Winter will come. Fall will come. Summer will come. Spring will come. Time is independent. It depends on nothing or no one. And just like time is always independent, one's choice is independent. If I go to McDonald's, for example, and I want to buy, whatever, a Big Mac, I can choose to buy one Big Mac or 3 Big Macs. I'm not saying that it's going to be very healthy for me, but I can choose to buy 1 or 3. I can choose to eat 1 slice of pizza or 5 slices of pizza. I can choose to study for 2 hours, or I can choose to study for 5 hours. I can choose to study every day a little bit, or I can choose to study the night before a test, which is not suggested, but it's still my choice. Okay? Just remember that. That's really important. So let's take a look at an example. Michael's weekly sales at ABC Car Loft is 0.8% of his weekly sales plus $500. So that's what he earns. He makes $500 plus he makes 8% of his weekly sales. The linear function s of x equals 0.008x plus 500. Let's see how I derive this, okay? 500 is my y-intercept because I'm going to get paid $500 whether I sell $10,000 in cars or 0 in cars. 0.008. How did I get that? Well, remember we can't work with percents. So 0.8%, if I go 1 to the left, that equals 0.008. So whenever we're working with percents, we must turn them into decimals. And why did I choose s of x? Okay, this is function s for sales with independent variable x, where x is the number of sales that I make in a week. Okay, so that function s of x equals 0.008x plus 500 represents Michael's weekly sales s as a linear function of his weekly sales x. So let's go through this. What is the implied domain? Okay, when they say implied domain, you have to look at this logically and you have to see, okay, what could the possible x values be? When we're not talking about real life scenarios, the domain of any linear function is always negative infinity to positive infinity. It's all real numbers. But this is a real life scenario. I cannot have negative sales. So my sales must be greater than or equal to 0. So my domain would be 0 to positive infinity. Now, some of you may say, Really, Mr. Morrow, you're going to have infinity number of sales? No, very doubtful. But that is a possibility, okay? You could theoretically, if you have the luckiest day of your life, just sell a car every 10 minutes when someone walks in. Doubtful, but it's still an implied domain. It's got to be greater than or equal to 0. Cannot be less than 0. You cannot have negative sales. Okay, B, if Michael sells a total of $50,000 in car sales in 1 week, what would his salary be for that week? This is the beauty of algebra. You're sitting there at home and you want to know, how much is my paycheck going to be this week? Well, $50,000 of sales, that's what X represents. So you plug it in. What are my sales for $50,000? I'm replacing the X with $50,000. So I would say 0.008 times $50,000 in sales plus my $500 that I get regardless just for going to work. So when you do the math, and by the way, yes, you can use a calculator for this. Okay, 0.008 times 50,000 is 400 plus 500. You're looking at $900. That will be your weekly earnings for that week, which isn't bad, okay? Not bad at all. Now, what if I say to you, if Michael earned $800 in 1 week, what was the value of the cars that he sold? Now, in this case, my friends, this is the S of X. This is the actual salary that you earned. I'm trying to find the X. I'm trying to find how much did I sell to earn $800 here. So in this case, it would be 800 because that is what you earned that week. That is S of X. What you earn, remember, is dependent on what you sold. So that equals 0.008 times X. That's what I'm looking for, the amount of sales that I had, plus $500. So I'm going to subtract 500 to both sides. And that's going to give me 300 equals 0.008x divided by 0.008 to both sides. And x will equal, I take 300 divided by 0.008. That gives me $37,500 in sales. That's how much I sold if I earned $800 in this check. Okay? Now, draw the graph of this function. I went ahead and set up a nice graph for you guys for this. Okay? Just because I want to show you how to do this. I am not going to do this for every single example that we have here today. That's going to be up to you to figure out how to do it. But use your head, okay? Use your logic, and I'll show you how to do that. First of all, when we're talking about real life scenarios, we can't have negatives. So that's why I just use the first quadrant, where the x and the y's must be positive. In this particular case, we know that the independent variable, the x, okay, is the weekly sales. And I put here in thousands of dollars. So where you see a 10 here, that's really 10,000, okay? And I know that my salary, my S of X, if I can put it here, my S of X, my salary, is dependent on X, so that's on my Y-axis. And here I put salary in hundreds. So for example, where I see a 9 here, it's not 9, it's 900. Okay? On the bottom, as you can see, I skipped a space in between, so I'm going by 5s. And on the Y, I just went by 1s. So, graphing this is going to be quite tedious. Quite tedious if I graph the way we normally graph, which is by plotting the y-intercept and then following the slope. It's going to be very, very difficult because my slope here is 8 thousandths. So it's going to be really tough to graph that. So let me explain how you would graph this accurately. First of all, right off the bat, you can always graph the y-intercept. Please remember, let me just bring it up here again, and let me copy it so we can see what we're working with here. Okay, we are working with here s of x equals 0.008x plus 500. So I know right off the bat that when x is 0, my y-intercept is 500. So I'm going to start right here at 500. Okay? So for this, basically what we're doing is we're making some tables. Okay, I don't need 100 million values. We just need some of them. And when x is 0, we got $500. Okay? Then let's go ahead and pick another value. Let's pick at least 2 more values. Depends how accurate you want this to be. Let's, for our sake, pick another 2 values. So let's go ahead and choose when the sales are, I don't know, $30,000. So when x is 30,000, okay, I've got 0.008 times 30,000 plus my 500. That's going to be 740. Okay, that's not really a good one, is it? Because we're going to have to estimate. So let's choose a little bit of a better one. How about this? Let's say when my sales are $50,000. My sales are $50,000. 50,000 times 0.008, if I'm not mistaken, is 400. Plus 500, that's $900. Okay. So when my sales are 50, my salary is 900. You feel me here? Hopefully you guys are making sense of this, okay? Right here, we've already got a slope, don't we? All right? I went up 1, 2, 3, 400, of course, and I went over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10,000. So do that again. Go up 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And guess what? That is your graph. So actually, you don't even need 3 points. You just need your y-intercept and then choose another point where you're going to have nice, beautiful, even numbers and then create a slope. Again, how did I find the slope? I went up 1, 2, 3, 4. 100, of course, but I went up 4 on my graph, and I went over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1,000, of course, but on my graph, I went up 4 over 10. And then again, I went up 4 over 10. And I can keep doing that forever. So once you have the y-intercept, which is easy, choose one point that gives you a nice even value for y, or your f of x, and then follow the slope. Okay? And that's going to be a lot easier than trying to graph this. If you try to graph that, like I said, that's 8 thousandths. You could do it, but it's going to be really hard because I'm going by hundreds on the y. I'm not going by ones. So it's going to be really impossible. You're going to have to do a lot of estimation. But the way we did it here, you don't have to estimate. You find 2 points, find the slope according to your graph, and you continue that slope. And then E. How many cars does Michael have to sell if he wants his weekly salary to exceed $1,800. This was worded kind of incorrectly. It's not how many cars does he have to sell. It's more how much money, money in car sales does Michael have to earn or make if he wants his weekly salary to exceed $1,800. Well, here they're telling you to set up an inequality, okay? They want you to find out how much does he have to sell. What is your X if you want your salary, which is S of X, to exceed $1,200 or $1,800? So this one's pretty easy. It's 0.008x plus $500. When is that going to be greater than $1,800? That's the goal. That's the goal. When is my salary going to be greater than $1,800? How much do I have to sell? Well, we know how to solve inequalities as well. Subtract 500 to both sides. So I've got 0.008x is greater than 1,300. Divide both sides by 0.008. And again, yes, you may use a calculator, my brothers. Okay, and you've got 1,300 divided by 0.008. And I've got to make more than $162,500 in sales in 1 week to make more than $1,800. And that's the beauty of math. That's the beauty of linear functions. That's the beauty of equations and graphing and slope and all that good stuff. That's the beauty. All right, let's continue. The easiest cost function is a linear cost function. There are a lot of different types of cost functions. You can have quadratic cost functions and all sorts of different cost functions. But the easiest is that of a linear cost function. And a linear cost function, bare bones, is C of x equals AX plus B. Okay, where of course C of x is the cost. That's your dependent. Okay, and B is called the fixed cost. Fixed costs are things like your rent or your mortgage, the salaries you have to pay your employees, your electricity bill, your water bill, supplies, fixed costs, costs that are not going to change. They're going to be there whether you're making a lot of money or not. You still have to pay them. Okay? So fixed costs of operating a business. A lot of different components go into fixed costs. And the A, okay, the A, my slope, right? The A are the costs of manufacturing or making one item. When you hear manufacturing costs, that's just the cost of making the item. Because it's going to cost something to make an item in addition to your fixed costs. Your fixed costs, like I said, may be the mortgage, the electricity bill, let's say the insurance on your company. That may be your fixed cost, just to make it easy. But your A, your cost of manufacturing, well, you got to pay someone to make it. You got to buy supplies to make whatever it is that you're making. Those are different costs, okay? And that is what's called your manufacturing or making costs. It's really manufacturing costs. And that's your A. So let's say that you own a bike shop which has a daily fixed cost of $1,500. That means that Every day, it costs $1,500 to just have the business. And each bike that you make costs $60 to make or manufacture. Write a linear function that expresses the cost of manufacturing X bikes in one day. Well, my cost function, my C of X, the cost of making a bike in one day equals $60 for every bike plus $1,500, which are my fixed costs. So whether I make 0 bikes or 1,000,000 bikes, I'm going to have to at least pay $1,500 for sure. What is the cost of manufacturing 6 bikes in one day? Well, just plug it in. What is the cost function when X is 6? X is the number of bikes. So 60 times 6 plus 1,500, that's 360 plus 1,500. So it will cost you $1,860 to make 6 bikes in one day. Now you can maybe understand why when you go to a bike shop, good bikes cost $300, $400, $500, $600, sometimes thousands of dollars. Because there's a fixed cost that business owner, he or she, has to pay. Plus there's a cost of making the bike, okay? Or buying the bike. Sometimes they don't make it, but they buy it. And let's say it costs them $60 to buy it. They can't sell it to you for $60 because they're going to lose money because they have to pay for rent, for storage, for electricity, employees, insurance. So just to give you an idea, that's why bikes can be very pricey. Now, how many bikes can be manufactured for $2,700? Well, in this case, they're giving you the cost already. They're giving you the C of X. My cost in this case will be $2,700. That equals $60 for every bike I manufacture X plus my $1,500 fixed cost. I want to know how many bikes can I make if I have $2,700 this week to spend. Well, I solve for X, which you know how to do very easily. This is 1,200 equals 60. X divided by 60, and X would be 20. So you can make 20 bikes for $2,700. And then you hope and pray that you sell those 20 bikes for what's called a markup. Okay? If you sell each of those bikes, let's just, just for giggles, let's say you sell each of those bikes for $350. Well, 350 times 20, 0.0000017. That's $7,000 that you make. If you take the $7,000 minus the $2,700 that you spent to make those 20 bikes, you're going to make $4,300 in 1 week. Not bad. Being that there's 52 weeks in a year, that's over $200,000 a year. And if you want an exact number, let's say you take 2 weeks off for vacation, 50 times 4,300 equals $215,000 that you'll make per year. And then, of course, there's taxes and other costs, but that's pretty much how a business works. Okay? One more, guys. Book value. Book value is the value of an asset, such as a building or a piece of machinery that a company uses to create its balance sheet. A balance sheet is basically a report that tells the business owner or owners what they have and what they owe, hence a balance. Your assets, what you have, should always equal your liabilities, which is what you owe. Some companies use what's called straight line depreciation to depreciate or decrease the value of their assets by a constant amount each year. As you guys know, things break. Notebooks break, shoes break, clothing gets holes in it. Houses, fall apart, wear and tear, roofs leak, plumbing breaks, light bulbs burn out. So everything decays, everything depreciates. And this depreciation or decrease, okay, has to be factored in when you have a business. So the amount of depreciation depends upon the useful life of the asset. Suppose that you own a moving company which just purchased new trucks for its drivers at a cost of $26,800 per truck. As a company, you will depreciate the trucks using a straight line method over 8 years. So that means that each truck depreciates by the following factor. If you take the 26,800 divided by 8 years, because that's going to be the life of your truck, there's a lot of wear and tear when you're moving, okay? A lot of wear and tear. That means that the value of your truck goes down by $3,350 every single year. At the end of those 8 years, your truck is pretty much worth nothing. If you can still use it, great, you're ahead of the game. But if not, it's useless already. It's worth nothing. So how would I write a linear function that expresses the book value V of each truck as a function of its age? Well, the function V of X, where V stands for book value, okay, and X is the number of years, is going to equal negative 3,350 for every X truck that I own. Okay, that is what depreciation is, plus what I paid for it. So that is the value, my book value, when I'm taking into consideration the truck that I bought and the depreciation. What is the implied domain for this linear function? Well, remember that I can't have a negative value. So since I think that this truck is going to last 8 years, my implied domain will be between 0 and 8 years. Okay? It could break down after year 2. But hopefully it stays strong and I can use it for the full 8 years. But between 0 and 8 years is my implied domain. I cannot say infinity here because after 8 years, the value of my truck is 0 and I cannot have negative values. What is the book value of each truck after 3 years? Well, plug it in. What is my value when X is 3? Well, I have negative 3,350 times 3, which is 3 years, plus my 26,800. So after 3 years, the value of my truck will be, let's see here, 333.50 times 3. So I'm looking at my value after 3 years of the truck will be $16,750. B, when will the book value of each car be $6,700? In this case, they're giving me the V of X. So I'm saying the value of my truck is $6,700. How many years until I get to that value? Well, it's simple. Solve for X. How many years have to pass for me to get to that value of 6,700? Well, I'm going to subtract 26,800 to both sides. And remember, signs are opposites, so you subtract as normal and keep the sign of the largest absolute value, which in this case will be negative $20,100 equals negative 3,350x divide by negative 3,350 to both sides, and x will equal 6 years. After 6 years, the value of my truck, each individual truck, is $6,700. All right, my friends? So we talked about cost, we talked about depreciation, sales commission, and hopefully this makes sense. I hope you learned a lot. Have a wonderful day. Thank you very much. I'll talk to you later. Bye-bye.